Hi and welcome to my presentation about the digital factory. First to myself, my name is Roman Roth and I am the Chief of DevOps and a partner at Zülke. I joined Zülke 21 years ago as a junior .NET engineer directly after the university. Then I became an expert software engineer, then an architect, and finally a consultant. And one thing that was always at my heart is how can we continuously deliver value, how can we automate things, and how can we ensure the quality of what we are building. And when the whole DevOps movement started, I jumped right on top of that, became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup we are doing, and I'm also one of the organizers of the DevOps Days Zurich, which is a 2-day conference in Zurich every year. And the DevOps Days, this is a global movement. In all of the big cities there are DevOps Days all around the world, and I am the president of the DevOps Days Zurich. Now you can see the whole DevOps topic lies very close to my heart. That's also why I have my own YouTube channel with over 100 videos all around DevOps architecture and leadership. And I also post and tweet a lot on the social media channels. So if you want to learn more about DevOps, then please join me on these channels. In my projects, I'm working for different clients in different industries doing DevOps transformation. So when I look at these companies, then usually I see this picture here. The clients, together with the business, they have great ideas. They put these plans into Word documents and into Jira tickets, and then they throw it over the wall of confusion to the development team. The development team looks at these Jira tickets and they say, yeah, if you want to have that, we can implement that. And they implement something. And then they throw it over the wall of confusion to the testing team. The testing team looks at the specification, looks at what has been built. It's not the same, but they test something. It's green, and they throw it over the wall of confusion to the operation team. The operation team is like, whoa, how can we operate that? That will never work in production. But somehow they manage to get it to work, and it goes back to the clients and to the business, and they are like, what is that? That's not what we wanted. This does not solve a problem. And what you can see in blue is the value stream. And the value stream is broken by these walls of confusion. And they are coming from the silo organization. We have the business silo. We usually have the development silo, the testing silo, the operation silo. And all of these units, they have different goals. So they are not aligned. They are not working on the same goal. So we have a missing alignment. Usually also you have very slow and ineffective processes. Security and quality is something you do afterwards, and there is a lot of cultural resistance. So where are these problems coming from? Now, when you look how we are doing software development, then we work in projects. In the past, we did waterfall projects. So we planned, designed, developed, deployed, reviewed, tested, and launched in large batches. This was the traditional model where the scope, the budget, and the time was fixed. This is how we do waterfall projects. We deliver in large batches. Then around the year 2000, some smart people said, yeah, this does not fit how we are developing software. We need to change. And of course, we changed. We now were delivering in smaller increments in an agile way where time and budget are fixed and the scope is variable. And this is how we deliver nowadays projects. But it's about products. Our clients, they want to have a product. Now for that, we need to understand a little bit more what's the difference between a project and a product. A project always focuses on the output. It is these number of features, for example, 10 features in that time for that money. That's what a project is all about. So it's about maximizing the number of stuff that gets delivered. Features, user story, tasks, code, whatever. On the other hand, we have the product. A product focuses on the outcome. So in a product, we want to understand the customer need. We want to solve the need of the customer, or we want to change the behavior of the customer. And there it goes about that one feature that solves the problem of the customer. And you can see this is a huge difference to a project. So one thing that helps us to go into this product thinking is DevOps, because DevOps is a mindset and culture and a set of technical practices which allows us to organize ourselves across the value stream, organize all the people across the value stream, and continuously deliver value. This is a very good methodology if you want to develop products. And when we talk about the people, we of course also need to have a look at the term DevOps. I must admit, the term DevOps is not very well chosen because it says development and operation. And before I said it is across the value stream, which includes all the people which are working on a product. So of course, some very intelligent people said, we need to fix that term. We need to call it DevSecOps because security is very, very important nowadays, which is development, security, and operations. And a bunch of people says, yeah, no, the business, they are very, very important. They are giving the money. So we need to call that DevOps, which is business, development, and operation. And you can see this whole discussion leads absolutely nowhere. We need sort of a term like DevSec, Bits, Arc, Comp, QA, Ops, and I'm pretty sure I have forgotten someone. We can also call it DevStarOps or DevXOps, or we could just call it DevOps. Because DevOps is all about bringing all the people, process, and technology together to continuously deliver value. This is what DevOps is. Now, why should you care about DevOps? Why is that important for you? So let's again look back in the year 2000. There were some small, funny, named companies like Netflix, Google, Facebook, which were experimenting with DevOps. And nowadays they are dominating the market because they have a massive rate of innovation that they can deliver to the market. Nowadays, we see the same happening in hardware. When you look at that, you can see that companies like SpaceX or Tesla are also experimenting exactly with that, and they will soon also dominate the market. So when we when we look at that, I can give you also an example on that. The example comes from Tesla, and you see here some tweets from Elon Musk, and you can think of Elon Musk whatever you want, but the interesting thing is what he is saying about how Tesla is doing that. So Elon Musk tweets on the 7th of October 2021 that the self-driving module or software module 10.2 will be rolled out on midnight to 1,000 owners with a perfect safety score, 100/100. What does that mean? What does that say to us? It says that the software of a Tesla is modularized in different modules and that they can do an over-the-air update. Not only that, they can also target a specific group of 1,000 people which have a perfect safety score, which means they are monitoring these cars. So there is quite a lot in there when you can target 1,000 owners, which it means that you can do canary releases. So already that is quite important, and it's quite an interesting thing. Now, then on the 15th of October, he said, okay, 10.3 can be rolled out because everything went fine. And again, we are doing a canary release to car owners with a safety score of 99 to 100. So again, here you can see they are constantly monitoring and getting feedback from the cars. Then on the 24th of October, he says, ooh, we have a problem. We have a problem with the 10.3 and we need to do a rollback to 10.2. Now, here we need to quickly stop. The whole automotive industry is regulated, which means that every release is under regulation. And what Elon Musk is doing here is he does a rollback to a previous version with an over-the-air update in Teslas, which are driving on the road. And this is quite astonishing because many companies are not able to do rollbacks when they are failing with something. And not even 24 hours later, he is saying, hey, everything is okay, we found the bug, we are rolling out 10.3.1. And this is also awesome because that's a fix forward. And you can already see how Tesla is moving forward in that field of DevOps and of continuously delivering value. Now, science has looked at DevOps, and you can also read that in the book, The Science of DevOps, which is called Accelerate. It's an absolutely amazing book, and I can highly recommend to you to read this book. Now, what they have found out is that there are 24 key capabilities which drive improvements in software delivery performance, and you can see them there. They also categorized these into 5 categories. There is the continuous delivery capability, the architecture capability, the lean management and monitoring capability, product and process capability, and the culture capability. And all of these 24 capabilities are needed in order to move fast. Let's quickly go through them. It's the continuous delivery capability. There you need to have everything under version control. Only then you can do fix forward or rollbacks, of course. Deployment automation is very important. Continuous integration, continuously integrating the code. Trunk-based development, so working on one trunk and continuously integrating into that. Test automation is an important thing. Also test data management and the whole shift left on security. Also continuous delivery capabilities. Also very important is the architecture capabilities, so that you have loosely coupled architectured and empowered teams. I always say have teams of 5 people with clear input and outputs, with clear interfaces that they are doing, and then you get that out of the box. Of course, it's not that simple as I said it, but that's the direction in which you need to move. And then the product and process capabilities with continuous customer feedback. You also saw that in this example of Tesla. They are getting the feedback. Then a value stream. You need to organize across the value stream. You need to know your value stream and to work in small batches, in small digestible batches. And team experimentation so that you can continuously improve. Then the lean management and monitoring capabilities, there it's very interesting. They found out that change approval processes are for nothing in the best case. In the worst case, they will slow you massively down. Also, monitoring capabilities are very important also for the productive notification, so that you get notified before your clients see the bug. The WIP limit is important, work in process limit, and visualizing the work with different dashboards or Kanbans. Cultural capabilities are also an important part. We have the Western organizational culture. There we distinguish between three cultures: the pathological culture, the bureaucratic culture, and the generative culture. The pathological culture, there, when you find an error or a failure or something that doesn't work, or if you have done something which is wrong, then you get sort of shot. In the bureaucratic culture, when you find something which is not good, or if you have done something which is not good, then a huge bureaucratic process will start, and they try to find out who is responsible for that. And then you have the third one, which is the generative culture. In there, when someone finds something or someone does an error, then everybody is like, wow, that's very good, we have learned something. So it's a learning culture. And of course, all of the companies want to go to the generative culture, but most of them are stuck in the bureaucratic culture. Which brings us, of course, to the supported learning. You want to have continuous learning culture. You want to collaborate across the teams, have a great job satisfaction. And for all of that, you need to have transformational leadership. So already finding out in a scientific way what the 24 key capabilities are for software delivery performance is already an awesome thing. But they also found out scientifically what the relationship between these things are. In simple words, you can say, when you want to achieve something on the right side, you need to implement that thing on the left side. And this is quite awesome. I highly recommend to always have that picture in mind or on your desktop, because it's a very important picture when you want to continuously deliver value, when you want to do DevOps, or when you want to build up a digital factory. Now, what is the benefit of DevOps? And again, here science has looked at that. There is these state of DevOps reports, which are done on a yearly basis, and they are always comparing the low performer with the high performer, and you can see the numbers are just massive in deployment frequency, in faster lead time, faster time to recovery, or a lower change failure rate. And when you summarize the benefits of DevOps, then you can clearly see that it is a faster time to market, more value for money, higher quality, higher customer satisfaction, and top qualified employees. Now, these are exactly the things that CIOs and all over the world in the companies want to achieve. So now, why is not everybody doing DevOps? Because, of course, there are some challenges which are coming with DevOps. Because you might remember I said DevOps is a mindset, a culture, and a set of technical practices which we need to apply across that value stream. And here are these technical practices which you need to apply in order to do modern software development and to create great products. And yes, these are quite a lot of technical practices you need to apply. Now, it gets even worse, because when we do DevOps, we say you build it, you run it, and you own your product. This means you need to have infrastructure, cloud, on-prem. You need to have a runtime, Docker, Kubernetes, a virtual machine. You need to have a CI/CD pipeline, GitLab, CircleCI, GitHub, whatever you want. Monitoring, you need to have Prometheus, Dynatrace, Datadog, so you need to choose. You need to have security, like Snyk, SonarQube, and so on. And of course, you need some supporting tools like Jira, Confluence, Miro, or whatever you would like to have. Then you need to do cost management over that, especially when you're in the cloud, of course. And you need to do maintenance on these tools because they need to be sort of integrated together. They, of course, also have updates, and you need to update them quite regularly. And you need to have access and identity on these tools. So you need to provide access to these tools, and you also need to remove some people on all of these tools. And oh, you just forgot, you also wanted to build your application, which is up there. And you can already see that's quite a lot when you want to own it. But it gets even worse, because usually what happens in companies, you have multiple products, which means you have that at scale. You have multiple of these stacks, which the teams are coming up with. And this means you introduce quite a lot of inconsistencies and redundancies. Every team reinvents sort of the wheel. There is also quite a lot of lack of operational experience. Synergies are not really used. And it's also not quite easy to move people from one team to another. So what you can see when you summarize that, the cognitive load is quite high. And yeah, hear me now. Can you scale at all DevOps? Is that not too difficult? Should we not quickly go back to the waterfall organizations and to our silos and just stay there because that DevOps thing does not work? I think it works, but for that, we quickly need to make a step back and think about what do we want to have as an organization. For that, we have here an example of a company which builds drones. I just put here drones because it's something you can touch and which is also very good to visualize. You can replace the drone with your software that you are building. It is just difficult to draw software. So here in this company, we have sort of the board level. On the board level, they have bold ideas. They currently create small drones. They only have a small market share and they want to go bold. Their vision is to increase their market share and to come up with different drones, perhaps a maintenance drone or perhaps a drone which can carry a lot of weight. So amazing ideas. They put that into a portfolio Kanban, and they are going to prioritize that. And they say the highest priority is to create a drone which can carry high weight. They give that down to the product level. There are the product managers. They take that and this prioritized epic and they think about how can we build a drone which can carry high loads. They are coming up with features of such a drone, which is the increased battery which you need another engine for that, and of course you need to update the software of such a drone. So they give that down to the existing teams where you have the product owners. And you have a product owner for the software, you have a product owner there for the battery, and they are getting this feature and they are cutting the feature down into user stories so that we can adapt the software and that we can adapt the battery. And you can see the teams are already working on their continuous delivery pipelines, on their continuous integration and continuous deployment pipelines, which are of course highly automated. But for the new motor, we need to have a new team, which needs to start. And here comes the platform engineering or the platform team into play. They are providing continuous delivery pipelines out of the box in a standardized way so that the teams can start with a no time delay. So with that, they can already start and we are going to assemble the whole drone, of course, completely, fully automated. There is a continuous integration and continuous delivery of this drone. The customer is happy, we get more value for the money, a faster time to market, better quality and top qualified employees. But here, this story does not end, because now we need to start monitoring. We need to monitor what is happening. Are the drones, is the software working like Elon Musk did it with the Tesla? Are the people happy with what they is delivered? And we need to feed that back to the teams so that they can continuously improve. But again, here the story does not end, because we need to feed back this information back to the board, because they need to decide. They want to increase the market share. They want to have happy customers. They want to have revenue, of course. And this means all of these information needs to go back to that board level so that they can make the right decision based on this data. And perhaps they are going to decide to stop this heavy lifting drone, or they are going to invest more into such a drone. And as you can see, this is what we call a digital factory. It's such a digital factory has on top the lean portfolio management, which connects the strategy with the execution. On the bottom, the foundation of such a digital factory is the platform plane, which develops and builds and maintains the platform which the teams are using to develop their products. Here you have a different view on this platform team. The platform itself is a product. It is something the teams want to use. That's a very important thing. And you can see such a platform has application runtime in there. It has devsecops in there. So all of the vulnerability scans are already in there. It provides access and identity to all of the tools. Of course, there is monitoring and observability in there, and a CI/CD pipeline. Everything is in there so that the teams can use that. Now, the important thing is the teams, they own their product. So they build and run and maintain their product, which means when the platform provides a CI/CD pipeline, it provides the ability to create CI/CD pipelines. The teams are doing the CI/CD pipeline. The teams are monitoring their application in production. It's not the platform team. They just enable the teams to do DevOps. And with that concept, you can see that the platform team generates value for the teams, while the product teams, they generate value for the customer. But here, the story does not end, because now we focused on that DevOps part on the platform. But to create truly amazing products, we need to have the digital factory. And in such a digital factory, of course, need to have architecture. We need to have small teams with clear inputs and outputs, with a modular approach, where we have an API-driven approach, where we have APIs, where these modules can be sticked in. So a good architecture is very important in order to build great products. And you also saw we need to gather quite a lot of data, make sense out of that data. That's why data is very important. And we need to put the customer into the center. We need to have a great end-to-end customer experience. And of course, because we are working with different teams, we need to have agile program delivery, which means we need to have multiple backlogs. We need to manage that. We also need to manage the dependencies between the teams. And on top of it, we need product management. There we are going to connect the strategy with the execution. And with that, you can deliver complex modern products. And you can see such a digital factory is a holistic approach. So As you see, we are entering the age of industrialized software development. With the platform engineering, we are building the platform, the foundation of these digital factories so that we can enable the teams to do DevOps and with that to continuously deliver value to the clients. And this is how we are building the digital factories and how we can continuously deliver value. Thank you very much.